Okay, what I want to talk about today is finite state machines. And I'll be honest, I did not make I've got some PowerPoint slides that I use for another class. They're really for VHDL, so I'm not going to use them for this class here. So I'm just going to kind of go through the explanation of what a finite state machine is, and I'll put some, I created a new notebook so that I can just print these notes to a PDF and put them online later. Okay, a finite state machine is basically a way of looking at a electronic circuit, a embedded system, or something like that in terms of states. Now, a state is a condition. It's in a particular condition. The easiest one, and the one we're going to look at here, is something like a red light, right there. So, when I want to look at an example of a finite state machine, I have an intersection right here, and I realize that I'm in Malaysia and that most people don't think in terms of north, east, south, and west. They think of, go to this intersection and turn toward Gombak or whatever. Well, the rest of the world, I shouldn't say the rest of the world, in North America at least, we tend to look at the map and say turn north, turn east, turn south, turn west, because those are absolutes right there. Unfortunately, I have to admit, driving around KL, I can see, or Malaysia, I can see why people don't do that, is because none of the roads go north, south, or east, west. They go in curves, winding out there. But so much with, I don't want to comment too much on the engineering design of the highway system in Southeast Asia, but obviously, we would say that these roads were designed by drunken Indians. In other words, they couldn't walk a straight line if you paid them. But if you go to a city like New York City, for example, you've got all the avenues will run east and west, and all the streets run north and south. So the corner of 5th and 7th would be 5th Avenue, and 7th Street would be at the corner of 5th. And all the addresses follow that there. So it's kind of an interesting way of looking at that there. But a well-designed city would have addresses that start in the town center at 001, and as you move east, it would be East 5th Avenue right there. The first block would be between 0 and 100. The second block would be between 100 and 200. And you would start here at there. That would be like Main Street or Main Avenue or whatever they call the center street. If you're in a county, it would be Meridian Road or Meridian Avenue right there. But regardless, a lot of the streets are in North America are in a grid right there. I don't see grids here typically in KL. At least I don't see a grid. I haven't seen a grid anywhere, other than maybe some neighborhoods might have a grid. But I know my address is something like 56 John 6 Strat 23B or something like that. The 56, obviously I don't know what the reference point is. It's probably the end of the road there. So you cannot tell from my address where I'm at in the city there. And on top of that, they'll reuse the name of the roads. So something like John 6/23B, there might be 6 of them in Kuala Lumpur. So I have to put comma and then the, whatever neighborhood I'm in. When I was in Kelong, I remember I had to put Taman Karina or something like that there. Kurina or something like that there. Now I have to put Danau-Kota, that there, or stop Danau-Kota / Stophock or something like that. In other words, I can't just put the address in the name of the city there. So, but regardless, I'm in an ideal situation where this is north, this is south, this is east, and this is west, okay? So, for sake of my discussion on stoplights, let's assume that we have a stoplight on a corner that has a north-south street and an east-west street. So, we can talk about the state where the north-south lanes, so let's just talk a simple stoplight. A simple stoplight means that there's no turn lanes and no arrows or anything like that. So if we have a state called north-south green, that means that this is a green light, and this is a green light, this is a red light, this is a red light, right there. So cars that are going north can go straight, right there. Cars that are going south, or I guess ones that are going north will be going up, they can go through the intersection. The ones that are going south could go through the intersection. Assuming nobody turns right in front of anybody, nobody gets hit. And nobody runs the east-west lights right there. That's, we're assuming that people are following the traffic rules here. That there. If somebody wants to turn right, say somebody wants to turn right here, they don't have an arrow, so they have to wait for an opening right there. Same thing here, if somebody wants to turn right, they have to wait for an opening right there. So that's one state. And then our next state would be north-south. We have a period where it goes yellow right there. Now, there, and during the yellow light, people are supposed to not enter the intersection, although they do, but we'll talk about that here in a minute. But they should prepare, if they're 100 meters back, 200 meters back, they should prepare to stop. In other words, they should not enter the intersection while the light is yellow, right there. If they're already in the intersection, they should proceed on through. They shouldn't stop their car and back up. In other words, they should just keep on going through. Or if they're within, say, 5-10 meters of the intersection, if they slammed on their brake, the car behind them who's checking their text messages, not paying attention to driving, will slam into the rear, right? So we will assume that, that some cars will enter the intersection, but you're not supposed to there. So I'm going to add another state that most stoplights don't have, and I'm going to call it a north-south red state, right there, where all the lights are red for a short period. There. And the reason for that is to accommodate people that try to run the yellow light. So in the red light, no one is supposed to be in the intersection. And if you had a police car or a camera there and it took a picture of a car that's in the middle of the intersection near the north-south red, they should get a ticket there. Now obviously that doesn't happen there. I know in Western countries, running a red light is a very serious offense, and you will always get a ticket if a policeman sees you. You will always get a ticket for running a red light, and it will cost you thousands of ringgits before it's done. The ticket itself will probably cost you $200 or $300 USD, which is between 400 and 600 ringgits. But then in most Western countries, your car insurance, when you buy your car insurance here, the only thing you show is the car grant, right? And they base the registration on, the insurance fee on the size of the engine of the car and the age of the car and the value of the car. And your driving record is not looked at. In most Western countries, the insurance company has access to the JPJ ticket file of how many people have had tickets, accidents, and all that stuff. They pull your file, and it's adjusted accordingly. An example of that is I had a wife, she's now an ex-wife, who she only knew two positions on the gasoline pedal or the throttle. Up, and the foot was on the brake, or full down. There was no in between. The car either went 160 kilometers an hour or stopped there. And she drove a little Mazda RX-8, which would go 160 to 170 kilometers an hour very easily there. Well, she could pass anything but a gas station and a squad car. She ended up getting 3 tickets for going over 140 kilometers an hour in a 2-year period. Her car insurance, at the time we separated everything, her car insurance was roughly in the neighborhood of about 400 to 500 ringgit per month. My car insurance was about 400 ringgits per year. So there's a, so as we look at, and actually that is a way of encouraging good driving. That there. So you actually give tickets, and then the insurance companies will. And the insurance company's philosophy on that is that if you're driving 160 kilometers an hour on a regular basis, when you do get into an accident, a lot of things are going to break and people are going to get hurt. That there. So, but regardless, we're going to put this north-south red light state in there just simply to accommodate the fact that we do have people that run the yellow light that try to get through. So we have a few seconds. And then we also have the other problem, and since I've started driving a little scooter or motorbike, I tend to get sucked into it, is people that anticipate the green light and leave before the light is green, right? That there. And motorcycles seem to be the most guilty parties in KL, at least. That there, the young gentleman is shaking his head. Yeah, you do it too, right? That there. I'm in a pack of motorcycles at the front of the line. I'm like everybody else. That's why I ride the scooters, so that I can bypass all the cars stuck in traffic out here. That there. So I'm sitting at the front of the line, and the light is still red. I see that light is yellow, getting ready to turn red, and all the bikes start taking off. And if I don't take off with them, I get horned and I get yelled at. So. Yeah, so regardless, this is the only place I've ever been where you get scolded for following the law. That there. But regardless, we have this north-south red state that there. And it's to accommodate those people that do take off early, that there, the light hasn't turned red, but they see everything's red, so they take off. Hopefully nobody's in the intersection. That there, or people that have run the yellow light and didn't quite make it are actually all out of the intersection before the people leave early, right there. Because I have actually seen a couple of pretty nasty motorbike car accidents from the combination of the bike leaving a little bit early and the car running the red light. I've seen that happen a couple of times. I don't know if anybody's familiar with down Alcota, that area there, but there's an intersection there on Jalan Langkawi and Jalan Ibu Kota, right there. In that corner, I've seen at least Platinum Walk. Do you know anybody know where Platinum Walk is? Right there. Platinum Walk there. KL Festival City, that area there. There's one corner that seems to be notorious. I see about once a month. I've seen, and I've been there about a year. I've lived in that address, and I've seen at least 12 accidents there. About once a month, I see a bike that takes off early and a car that runs the red light get nailed. That particular corner, because of that, I don't run the red light early. I don't jump the light. I wait till I see everybody's through, because they are notorious on that corner for running that red light there. So, all right. Then our next state is we're going to go to an east-west green. Then we go to an east-west. Get my pen. Is, I guess, actually, I don't know what's going on with this pen. This computer is about, it's getting close to 2 years old now. East-west yellow, and then we do the east-west red thing, and I'm not going to repeat that, and then we refer back to this right here. But this is a finite state machine right there. Is that we've got, in this particular case, I've shown 6 major states right there. So, now, typically when people talk about finite state machines, they do it with a bubble graph right there. Now, in this particular case, I'm going to show the bubble graph, and I'm going to start with north-south green right here. Right here. And then I'm going to show here something here, delay. And let's say, for sake of our argument, that our north-south green is going to be green for, I'm going to say 30 seconds right there. Now, if this was a real traffic light, 30 seconds is a reasonable number. When you do this in the lab, trust me, you'll shorten that to like 5 seconds, because 30 seconds when you're watching this in the lab is a long time right there. So, that there. So, but we'll say delay 30 seconds right there. And then we go to north-south yellow, and then we're going to stay in our yellow state for, we'll say, 10 seconds right there. And my pen is doing all kinds of funky things right there. And then I go NSS, I don't know what I've got going here, but this is supposed to be 1S, north-south yellow. And then we go to north-south red, and we're going to just stay in there for 5 seconds right there. In other words, just give 5 seconds for the intersection to clear out. And then we're going to go to east-west green, repeat again, 30 seconds. Then we're going to go to east-west yellow, 10 seconds. East-west red, 5 seconds. And then we go back like that there. But this is a typical way that we would represent a bubble graph. Now, if you go through the web and you look at bubble graph representations and discussions of that they'll get into all kinds of theory about sequence encoders and all that stuff. I want to just keep this simple. I believe in simple and effective is good enough that there. Now, the reason I talk about finite state machines, and you're going to spend most of the rest of the semester looking at these in your final project, along with I'm going to throw in one lab on the analog to digital converter, which we won't be using in the final project, and I will probably have a demo on the LCD, but I promised that a long time ago, and I just haven't put it together yet. But I'll probably just cheat and use the Arduino because it's so simple that there. And the reason I'm going to use the Arduino is because it's got a 5-volt supply on it, and I can run the LCD directly. Okay, that there. Now, we can do finite state machines with any technology we want, right there. There's supposed to be a section, depending on who taught basic digital, where you did this with digital circuits, right there. Right there. You could do it with VHDL or Verilog for FPGAs or gate array designs with the digital circuits that there. Or we could do it with embedded systems using assembly language, which is a pain in the neck. You can do it with assembly language that there. The way we're going to do it is we're just going to use standard C right there. So, and I've got an example I'm going to kind of go through on this right there. And let me just kind of jump to this example here, right here. And this is an example I just copied off the web right there, and I will post this at there. Actually, it just comes from Wikipedia is where it came from. I just stole it this morning out there, so I didn't have to hype up an example that there. But this is a finite state machine that's got 2 states right there. This is defining a car radio CD player. So it's got 2 states. One state it's in radio mode. The other state it's in CD mode right there. So we're assuming that it's got 2 states of operation right there. So we've got another variable in here which we call event mode or events, and it's got event mode and event next right there. So the mode is to tell it to switch from radio to CD or CD to radio, and the next means next channel or next track on the CD player right there. So right there. So we've got our states are right there, is that we've defined our state machine. In this particular case, we're going to use this type def right there, and we're going to put in there those 6 states that I put. In other words, our states, instead of SD radio and SDCB, would be north-south green, north-south yellow, north-south red, east-west green, east-west yellow, east-west red. So instead of these 2 states here, we would list all of our states right there. So you have to list all possible states in your state machine right there. We don't have the second one. The second one we won't have it that there, because I'm going to go through and write what ours should look like here in a few minutes that there. And then tomorrow you're going to go through and Well, some of you tomorrow will go through and do the lab, and I'll talk about it. The other half will do it on Monday. This lab it will take longer than the last one. I should warn you, it's not, and you will have a small report to write for this one out there. But this one requires using the time delay from the last one. That's what, the last one was kind of prepping for this lab here, out there. So, because you need the time delay for that particular one, and that there. So, okay. So in our main routine, we have our states. We're going to find a variable called state, and it's going to have only two allowable variables. We have a track number and a station number. While one, which for those who don't remember, while one means while hell hasn't frozen over, or while the sun is still in the sky, or while the earth is still rotating. We won't say forever, because there are events that will probably cause us to fail. But we're going to assume while our code is running, we're going to just stay and just run this code right there. Now, there is a structure in C called the switch command. It's a switch case statement right there. And let me just kind of go through here. That there is that we've got, when we look at the switch state, that there switch, and then we put a variable name, and I'm just going to put state in here, because state is probably what we're going to call it. And I think I'm stopping someplace on the way home tonight or tomorrow, and or this weekend, and getting a new 4A pit battery if I can find them. I don't know. I think not Harvey Norman. I think Singhang sells them, right? State, right there. All right. This is a variable, right there, and we declare this variable as an enumerated type, right there, right there. And the structure for an enumerated type is right here, right there. Type def, ENUM, enumerated, bracket, and a list of all our possible states right there. So in our case, we would change this to right there. And this is in Word, but I'm just going to show you what it would look like. And normally you put them all in capital letters. North, south, green. North, south, yellow. North, south, red. East, west, green. East, west, yellow. East, west, red. Right there. That's what yours should look like. Now, you don't have to put each state on a separate line. You can just put them all in one row if you wanted to. Right there. C doesn't care about line feeds or spaces. Right there. But there, typically most people would put them this way though. Right there. So that lists all our states. So we have that there. Right there. So we would define state there equals. And we would tell it normally here. Again, I'm just editing this code instead of writing it simply because it's, it might be easier to see that their state. We'll start with our north, south, green as our initial state right there. So we declare a variable called state, and its initial state is going to be north, south, green right there. So, matter of fact, I'm just going to go through and just edit this whole thing, and I'll post it after I edit it right there. Now, this is, when I get done with this is not ready to run because you have to incorporate it in with the rest. This here needs to be added. This includes standard IO.h. That would include our, was it C850, 8051, F850.h or something like that, or I can't remember what the name of the file is, but it would include that file right there. That there, but this is, everything. Matter of fact, I'm just going to delete that right there. And I'll just simply say include normal stuff right there. Include all the normal stuff that you get from Blinky right there. All that normal stuff that's there. And in main, you will also put before this right here, you will put in here your watchdog timer. I'm just going to put some comments here. Watchdog timer disable. What else will we use? Output initialize right there. So you have to do the initialization of your input output that there. What else did you have there? You'd have to do your initialize timer 2. That has to be done right there because we're going to do, and again you would use what we did last week right there. You would have to initialize timer 2, and then you would also put in there header for delay right there. You'd also have to include in here initialize timer 2, and I'm just putting comments and things that you have to do right there. And initialize interrupts right there. You have to enable the interrupts. All that stuff from last week you have to include right there because you're using you're using the delay, so you have to initialize the timer interrupt. You have to initialize. You have to put the header in for delay. You have to put in the interrupt service routine. All that stuff that you did last week has to be incorporated into this program right there. And when you initialize the I/O, keep in mind that we're going to be using 6 outputs, so you're going to have to use one of the ports, and you're going to have to set 6 of the outputs to. I would just do the whole port and just write 0F to that particular port to put the whole 8 bits as output pins right there. Because we're going to use another one for the turn signal right there. So later on, so just go ahead and use all one of the ports. I think port 1 is set up for output right now. So, and then also keep in mind that you're also going to be doing wiring up LEDs for this particular lab. You're going to have 6 LEDs that you need to wire up, and I'll talk about that at the end here. So, okay, but as we look at this right here, this is all the stuff right here from previous labs. You just have to go through and pick those pieces out and put them in there. Pretty much 90% of it's done, right, or in last week's. If you start with that one, then you're probably in pretty good shape right there. So, all right. So we're not going to worry about this here. Since I'm deleting this and actually starting this here. So we're going to, right here, and what we're going to basically do is on our switch case, right here, we're going to have, and I'm going to delete this code right here, and we'll talk about right here. This is our first case right there. And our first case is case right here. This is our first case right here. And this is going to be north, south, green right there. Now, the only thing we're going to do in north-south green right here is we're going to just do 2 things. We have to set up a variable here, up here. And one of the variables we need to do is, and this is in words, so, and lights, right there, and actually lights right there, and I'm not going to put the code for it here. I'm just going to put a comment right up here at the top here that define lights as port 1 right there. So look up the code for that. So we're going to say that whenever we talk about lights, it's port 1 right there. Now, when we wire our lights, one of the things that I have not talked about when we wire our lights right there is that we're going to wire them through a 330 or a 220 ohm resistor. I don't remember which one she's got up there. Through the LED and then to the port 1.X right there. When you wire it this way, when you write a 0, the light is on. When you write a 1, the light is off right there. So keep that in mind right there is how we're going to, when we do this. So you probably want to do a table right there. And it's a relatively simple table right there. I'm going to say we're using port 1. I don't remember which port. I think I got the lab here. Right there, and okay, I don't even tell you what port to use. So the ports right there, and these are the timings on the lab that are there. And I posted this on Facebook, I think, just before class, right there. So some of you that keep your Facebooks on all the time probably seen this file right there. So okay, but this basically, and it's written as that there. Okay, actually, if you look at this right here, one of the assignments was to do what we did last week, was to write delay. I just discovered last semester that they spent an entire week on just getting delay to work, so I just gave it to you and said, here it is. Now you have to use it right there. So, and I didn't want that to be the major part of the lab. Right there. Okay, but we're going to say we're going to use port 1, and let's just look for a second, just see if that's good, if that's accurate. Right there, tool stick, here it is. Oh. Our push buttons are on, where are our push buttons? Right there, I don't see where our push buttons are. There's power, port 1.3. Oh, this is not our tool stick. No wonder it doesn't look right. Here's our tool stick. Right there. Okay, port 1 actually has one push button on it, so port 0 is free. So you use port 0 for the, we're going to use port 0 for the output, okay? The only problem is if you use port 1 and you accidentally push that button, and we're going to use these two buttons later on, right there. So if you use these inputs right here, and you push that button while that light is on or off, you could burn up the chip. So use port 0 right there. And then remember, you're going to have to pull off from these pins down here. Here's port 0.7, port 0.3, and port 0 starts here, and you'll have to come off using the jumper cables to drive the LEDs. So and you're probably going to be, can I make a suggestion that you bring a prototyping board? Everyone should have one of them from your circuits course, a breadboard. And you don't have a breadboard, somebody in your lab group is going to have a breadboard, okay? Got there. Bring a breadboard and wire up the LEDs, because you're probably not going to finish this tomorrow. You're probably going to have to go into next week. Got there. And wire up the breadboard with your LEDs and your resistors, and then have your 6 jumpers to go onto the back of this board right there. That way, next week you don't start wiring from scratch again. Right there. So you might be able to do this in one class. Honestly, I could probably do the lab in probably half an hour, but I discovered it takes at least 1 or 2 classes for people to do this with. Right there. So again, and I'll be here at 8 o'clock although no one else is going to show up at 8 o'clock, although I don't think the room's used after that. We can run till 10:30, I think, if we need to get the full 2 hours. But we're going to use port 0, so you start here, and you take your jumpers around that there, off the back, that there. And again, those are hooked up right there. So this is port 0.x right there. So you go through, and this is going to be 3.3 volts, and you take that off the board. Go ahead and pull the 3.3 volts off the board right there, and there's a place where you can jump to that from right there off the board, that there. And so you take your 3.3 volts off the board and you bring it around to that there, because as we look at the board, right here, they don't bring it off here. They've got the ground. You also got to bring ground off too. Actually, yeah. No, you don't have to bring ground because you don't have to connect anything to ground. But the 3.3 volts comes off right here. Hopefully she's got that connected up that there. So the 3.3 is going to come off of that there. Actually, we tried doing that with the LCD, as we recalled, and the LCD would not use 3.3 volts. So the 3.3 volts will come off of there. So when you go back to this drawing here, this goes to the VDD on the board right there. So, and you can just put that along the top of your board right here. Just bring your 3.3 volts out, and then bring your 6 resistors over here. Remember that there's a jump of space in the middle of the board, so right there. And you don't have to hook up the ground up there. So then you would bring your other 6 connectors off here. So you'd have 7 connectors to the board right there. So you have 7 connectors to the board, 6 of which will go to port 0. The other one will go to VDD right there. So you have 6 connectors going off the board right there. Okay. Now, where I was going at is that I was going to say you need to do a table right here. And our table is you list all the states. East-west green, east-west yellow, we're still, okay. I hit the wrong button. Okay, east-west yellow and east-west red. Now, what I'm going to list here is state, and I can't spell state right there, and port 0 right there. 7, 6, 5, 4, 3, 2, 1, 0. Right there. Now, it doesn't matter what you do with this, but what you want to do is you want to specify what LED is going to go to what pin on port 0. Now, what I'm going to do, knowing that I'm going to give you a second part of this assignment where I'm going to add turn lanes, and I'm going to add push buttons for the turn lanes and things like that, I'm going to say use the upper 4 bits for north-south and the lower 4 bits for east and west. So this is, and I'm just going to write them down here. So we've got, and this is going to be kind of, in the north-south lanes, we got a red, a yellow, a green light right there. So I'm going to assign those to bits 7, 6, 5. Bit 4 will not be hooked up right now. We're just going to leave that right there. East-west, we're going to use 3, 2, and 1. So we won't be using ports 4, pins 4 and 0 for right now. That's reserved for later on, right there. So we've got, those are our pins that there. And also remember that 1 equals off, 0 equals on, right there. And what we want to do is we want to create this table, and we don't have to create these tables. We could assign our pins one by one. That'd be a pain in the neck and generate some very long code, because you'd have to have 6 lines for every time you want to turn on and turn off your LEDs. It'd be easier to just do it with 1 right there. So as we go through here, if this is our north-south, this is our east-west, right? So north-south green, right there, we know that we want our green light to be on and our red light to be on, right? We just go through and put our 0s and 1s, right there. North-south, our green light is bit 5. East-west, our red light is bit 3. Everything else is a 1, right there. Because we want those lights to be off, right there. East-west, the red light is bit 7, the green light is bit 6, the green light is bit 5. So, and remember the way we've got this wired, a 1 turns the light off, a 0 turns the light on. Bit 4 doesn't matter. It's not hooked up right now. So bit 4 is ignored, so I'm just going to leave it as a 1. I can make it a 0 if I want. It doesn't matter. Bit 4 all the way through here is a don't care. Just like bit 0 is a don't care. We don't care what those are. So you can make them a 1 or a 0 if you want. Right there. They're not used this week or the next 2 weeks. They will be used the last few weeks. So that's why I'm writing a 1 to them, because later on we're going to put a light on that one there. And we're going to have a state where we're going to be adding we're going to be adding 4 or 5 more states to our table. We're going to make this more complicated right there. Now we just want to get a very simple light, and all it does is green, red, yellow, red, 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 green, red, green, red, yellow, red, red, green, red. I mean, just all it does is just go through the sequence. It doesn't do anything right there other than that there. And it's a very simple stoplight like you would see on a corner without any turn lanes. All right, the next one is we're going to turn on the yellow light, and we're going to leave the red light on right there. So it's going to be 1, 1, 1, 1. And again, I'm going to leave these all as 1s. And the reason I'm going to leave them all as 1s is we have to specify them as a 1 or 0. We can't put an X in our code right there. So we go ahead and just specify them as all 1s right there. So this is going to be a red, 0, and this is a red, 1, 1, 1, 1. And we go through the same thing again. This is going to be a 0, this is going to be a 1, 0, 0. This is going to be a 0, 1, 1. 1, 0, 0, 1, 0, 0, 1, 0, 0. Okay. We just fill out this table. Right there. It starts out with green, yellow, red. Then it comes over here, red, red. Right there. And then it's green, yellow, and this is wrong. This is wrong. I just screwed up. This should be 0, 1, 1. 0, 1, 1 right there. Yeah. These are east-west right here. These 4 here. Yeah, east-west yellow is right here. Right. Oh, again, I started messing these up here. I've got these all messed up here. my brain is just now, this should be a red, red, and red, 1, 1, 1, 1, 1, 1. Okay. That there. Right there. These, all 4 of these should have a red there. All 4 of these should have a red here. Yeah, well, these 3 and then this one down here should have a red. So there should be 4 states each. That there. And sometimes okay, sometimes it's easier to do it with an Excel spreadsheet right there. So when I do this right here, and I'm just going to put north-south red light, north-south yellow, north-south green, east-west red, east-west yellow, and no, not used, east-west red, east-west yellow, east-west green, not used. Okay, so again, this is the same information. I think this is a little clearer right there. It's, you know, sometimes you have to, right there. So in this particular case, I'm going to put a note down here. 1 equals off, 0 equals on, right there. So when we're north-south green, we want our red light to be off, right? Or on. Or we want it to be off, so we write a 1 to it. Our yellow, we write a 1 to it. And we write a 0 to this. I'm just going to put a 1 here, even though it's not used. Our red is going to be a 0, 1, 1, 1. Right here. Our yellow, we're going to write a 1 here, a 0 to this, a 1 here, a 1 here, a 0 here, that's still on, 1, 1, 1. North-south red, our red is going to be on, 1, 1, 1, 1, excuse me, 0, 1, 1, 1. Here is going to be a 0 still, a 1. 1 here, a 1 here, a 1 here. This is going to be a 1, a 1, a 0, a 1. Is that right? East-west should be, yeah. North, this should be a 0, a 1, a 1, a 1, a 1, a 0, a 1, and a 1. This should be a 0, a 1, a 1, a 1, a 0, a 1, a 1, a 1. Okay. East-west red means that both lights are red. for a short period. So that I turn this light, this is yellow. So does that look right to everybody? Does everybody understand what I've done there? Because our next step here is we're going to turn right around and we're going to put another here, and I'm just going to say lights. And I'm just going to put under lights here, I'm going to put the binary, the hexadecimal code in which is there. So 1101 is what? That is what, D? Does anybody remember their hexabinary? That looks like D8. D7, excuse me. Because it's going to be, it's 1101 space 0111. So what is that? I mean, and we could put it in binary if you want, if it's easier. But that looks like it's, that is D7 is what that looks like to me right there. D7, okay. So I'm just going to write D7 there. The next one is 1011. So that is, let's see, 101. So what's that? B7? B7. The next one is 77. And then this one is 7 and 110. It looks like D right there. The next one should 7B, and this should be 77 again. Right there. So again, the idea of this code, this page here, is that as I write my code, I can just simply look up this page, look this up. And you see, I like Excel for this. I'm sitting here doing it by hand, but in reality, you should just bring up Excel. It's you make fewer mistakes right there. And you can actually write code to do that there. So I'm just going to move this page over to here. And I'm just going to come down to here and right here, north, south, green. All I'm going to do here is I'm just going to say lights is equal to zero x 0 D7 right there. Delay 30. Break. Right there. Then I just simply copy that. Right here. Now I guess it's going to go there. It doesn't really matter. But then the next one is B7. And we change this to a yellow. And delay. I said yellow was 10, right? And we repeat that for all 6 states. That's the entire project right there. Right there. And then at the end of this, get rid of this right here. This right there. And again, it looks like there's a whole bunch of these things here. I think there's some extras here. There should only be There should only be 2 of those, one for the switch and one for the while, yeah. Yeah, so this here is the bulk of what your code should look like right here. Right here. And file, let me do a save as. Microcontroller Part 1 start right there. So I'll post this on Facebook later to give you a start out there. So, okay, you had some questions out there. Yeah. Okay, this code here, you have to look back at some of your other programs to look at there. But if you look back at let's look at Blinky, for example. Right there, let's just look at Blinky. And we want Blinky C. I think it's on the top level. Yep. Oh, well, this sets up. It's not SPID. You can't use SPID. There's a command that you have to use for out there, and I can't remember off the top of my head. I'll give it to you tomorrow if you don't find it in some of the other programs. But it's an equate sign. It's a symbol that they're where this sets up an SPID. We don't want to use SPID. We want to just simply do a constant, equate. Because again, what we're doing here is we're wanting to set up a port is equal to that there. And actually what you would do is you just say port 0 is equal to, right there, port 0 is equal to, there. In other words, instead of saying lights, you can just say port 0. So you just want to do an equate. I don't have, right there. But what this equate, let's go back to this right here. Here's my code. It's right here. What you want to do is you want to say define port 0 equals, or lights equals port 0. And I can't remember the exact syntax on the top of my head. But what you want to do is you want to just call lights port 0. If you can't find it, just use P0. So in other words, instead of saying lights down here, I can just say P0 right there. Say P0 is port 0, and that's your lights. But normally you would use an equate or a definition, define, to say that the word lights really means port 0 right there, is what you want to say. But if I can't find that there, and I just drew a complete blank when I was writing this up this morning, what is that there? Because I've been doing some VHDL work in another class, or not another class, but another project I'm working on. And it's different VHDL, so I get myself confused between languages. I have to admit that there. As much as I've done in C, I've also done as much work in VHDL that there, and as a result, I get the two languages mixed up. They're very similar to each other. That there, you don't learn much VHDL in your program, but my previous program, I did a lot of VHDL, and I do some projects in VHDL at home for fun. So I like VHDL. It's a nice little language. But and I've also been using the Arduino, which is a different language. That uses a something called just drew a blank. It's not Java. It's the it doesn't matter. But there's so many languages. But you could use port 0 instead of lights. It's the same thing right there. But there's a command that, and I'm thinking it's equate, but equate may be that there. If I had the internet, I could look it up real quick. Right there. I thought that Blinky gave it to us, but it doesn't. Right there. And I know one of the other examples does right here. Let me look up one more here. Yeah, right here it is. This is the command right there. That's the command I'm looking for. Define lights space P0 right there. That's the command I'm looking for. And as I said, I knew it was something very simple right there. So going back to our right here, the command for that is define lights P0 right there. That's all I was saying there. And then anytime you use the word lights down here, the compiler replaces it with P0. That's all that command does. As it goes through the code, and if it sees the word lights, it just replaces it with P0. And it just makes your code more readable than if you say P0. But P0 works perfectly fine right there. So again, I just, for whatever reason, as I was typing this up between yesterday and last night, I just, when I was going through what I was going to say, I just drew a blank. What's the command for define in C? Right there, and it's define right there. So, okay, let me want to see one other thing. Is there a semicolon right there? Open with. No, there's no semicolon at the end of it right there. So, again, going back to our code right here, again, you're going to include normal stuff, and then I'm going to put a note here, including delay functions right there. So again, remember that we have to put the delay in here. Everything from Monday or last Friday's lab this has to be added to that right there. So I would just start with that right there. Now again, you'll have to look at the code for delay right there. Let me look at the code for delay right here. Actually, we can just probably pull up this one right here. Open with Notepad. This lab here we'll do later here, but port initialize right here. You got to do the system clock initialization, although you don't have to there. The port initialize right here, set enable LED port as an analog port that there, enable the crossbar as LED. I just port 0 dot mode out is equal to 0x 8 is what you would put there. In other words, you want all 8 outputs to be push-pull outputs right there on port 0. So you would, and then you don't need this line here, but let me just grab this. Let me just grab this and stick it in there. Right there. I'm just going to kind of stick this down here, right there, and you don't need that one there, but this should be 08, and that's port mode, port 1 mode out, port 0 right there. So because we're using port 0 as I mentioned, right there. So you want all 8 bits to be push-pull, so you just write a 0, 1 to that there. And again, that's the same thing as if you would brought up and I showed this before, the configuration wizard. If I brought that up, right here, if I brought that up in options, peripherals, port IO, and enable the crossbar right there, and then you want port 0 to be all open drain. right there. And I guess it's 0FF right there, 0FF. I put 0F, it should be 0FF right there. Yeah, for whatever reason, I don't know why I put that there. I completely messed that up. Right there, yeah. Right there. And you can just simply say right there. You see, you could just go through and use that to set that up. But all I'm doing is I'm just telling it that those 8 bits are, when I said 0F, I was only doing the bottom 4 bits. I want to do all 8 bits, so it should be FF right there. So, and that there, so again, you have to do that. You have to set up those 8 bits to be push-pull. So you have to initialize those 8 bits right there. And again, I went back and pulled up the configuration wizard to help me out a little bit. Yeah, that's the same 2 commands I just put in there, right there. So I know I did it right. Right there. So this initializer port. So in the beginning here, you have to call port. What did I call that function? Port initial, port init. Port init. You just call that function right there. Again, you'll see that called in various other ones. Again, you initialize the timer, and again, that's all done like, that there. But that's your port initialization right there. And that, again, that was in the code that you ran yesterday, or earlier this week, or last Friday. So everything in Blinky that you ran, that there is going to be somewhat you need everything from that program right there. The only thing is that there is at the end of, actually you don't change anything because main you're replacing with this finite state machine. Because the only thing that was in main, as you recall, was you just simply called delay and then toggle the LED. Here you replace main with this here, with this state switch machine. So you're not going to just call here, but you call delay after every state call right there. And actually, we left one thing out here. I left one very important thing out, and this is very important. I'm glad I remember, and that is state is equal to NSY. We got to tell it to go to the next state right there. And same thing here is state equals NS red right there, and you got to put that in each and every one right there. So we set the lights whenever we go into a state. We set the lights, we delay, and then we tell it what the next state is going to be right there. So we have to have those 3 things in every line, and then we break out, and it comes back around and looks at the next state and does that right there. So that is essentially what you have to do that there. It's a straightforward. I've got you started. You should be able to finish this one. If you're not able to finish this one, then I'm not sure what to say at this point, because it's all you do is just repeat 3 times what I did right there. But then the wiring, remember the wiring? And somewhere I showed the wiring there somewhere. Here's the wiring right here. There's the wiring diagram. That's how you wire it up. So she has the red LEDs, green LEDs, and yellow LEDs in the lab tech. I'll get the box tomorrow from her that there, along with the resistors. Bring a prototyping board or a breadboard. Hopefully, at least each lab group has got a breadboard. And the reason I want you to bring the breadboard is I want you to keep the circuit on the breadboard for next week and the week after, because you're going to need that breadboard to keep adding, because otherwise you're going to have to rewire this every class, and that's going to take you 20-30 minutes out of every class to wire this up. So you want to leave, even if you finish the lab tomorrow, leave it wired up and keep it, that there. You should be able to finish this, that there tomorrow, you know, that there. Because then we can add to the next one, that there, because that there. So, all right, I'm going to wrap up here. Let me, before I wrap up here, print color mode, and I want to print to a PDF file. And this thing here, it's going to print to a PDF file, but it's going to be, actually if I do the Adobe, it looks like it keeps the, it looks like it's going to print it kind of weird, that there are 2 pages, 2 pages, but I'll go ahead and print it. And you know, I'm just going to put it under Lab 2. To a lecture. Right there. I'll just print this document. I don't know how useful it'll be. I think what's going to be more useful is this spreadsheet. Save as. I'm going to put it that there. Stoplight table. I'll just call it that right there. And I'm just putting it under Lab 2. So I'll put the spreadsheet up, and then the other thing I'll put up is this stoplight part 1. Where did I save this? Save as. And I'm going to put Lab 2 as well. Put them all 3. So I need to print those. I'll put those 3 files up right there. So again, this file is just a start. This is not finished. Every now and then I get somebody that goes into the lab and they'll cut and paste this and try to run this and say that the project's done. This one is not done. This is just started. There's all kinds of hints and things that you need to add to it right here. Again, Blinky has all this in it. You know, the Blinky from last week has all that in it there. So the only thing that's different is this define lights is not in Blinky right there, because we only had the one light there, the LED. So you want to take that one out and replace it with this one here, right there. And then this just starts for the first 2 states. I did ported net for you right there. That one I did do for you. The rest of them are the same as Blinky right there. So, okay, with that said, I am going to stop this. And I talk, yeah.